Okay, question 16 to 18 of the Maths June 2018 Unit 1 paper. Question 16 is about circle theorems. There's quite a few circle theorems. The one that we need here is called cyclic quadrilateral. The circle theorem about cyclic quadrilaterals tells you that the opposite angles of a quadrilateral, where all four corners of the quadrilateral are in contact with the circumference, will add to 180. So angle B down the bottom plus angle D at the very top will come to a total of 180. With this angle here being 71, this angle here must be 109, so that they can make 180 together. As you're looking at the triangle, the X corner, the X angle is here in this small triangle at the top of the picture. The angles in this triangle must add up to 180, like every other. So the 109 and the 26 that I now know about come to a total of 135, leaving just 45 degrees for the X angle. Question 16 is a construction question, and for a construction question you're going to need to see your teacher in class. They'll have to run through that in person. There's also a really good video on the Jones the Sum subscription where they go through construction step by step. Question 18. Question 18 is a proof question. These can be quite tricky. You need to prove step by step everything that you know so that you can get to find enough information that without a shadow of a doubt AX equals BX. For AX to equal BX, we're expecting to see two sides of that triangle are the same. For two sides of the triangle to be same, two of the corners must also be equal. So we're looking to prove that the triangle here, AXB, that has AX and BX in it, is actually an equilateral triangle. If we can show that it's an equilateral triangle, we can show that AX is equal in length to BX. So starting on the diagram with the 80 degrees that I know here, from my information, and the 40 degrees that I know here, from my information, I can also see that they've told me BX is the same length as BC. So I'm starting with quite a lot of information about that little triangle. Remember that if two sides are the same length, two angles are the same size. We're going to use that later. So angle X, called BXC, so angle X marked on the diagram, is equal to 80 degrees. And the reason behind that is triangle BXC is isosceles as BX is the same length as BC. So if they're the same length, the angles at the bottom of those sides must be the same size. Second to that, angle AXB, this angle here, must be 100 degrees. I know this because there are two angles to make a straight line. So I can explain that by saying AXB equals 100 degrees. Reason, AXB add CXB equals or implies straight line, and angles add to 180. This now gives me information in the triangle that I'm interested in. This now gives me information in the triangle here. So I now know that that's 100 degrees at the top and 40 degrees in corner A. If I work out the size of corner B here, ABX equals 40 degrees. I know this because the three corners in my second triangle must add up to 180. Reason, triangle ABX angles add to 180, which means that I've now got proof that these two angles are the same. So as XAB equals ABX, corner A, corner B, equal 40 degrees, triangle ABX is isosceles, and AX must equal BX as required at the start of the question.